back to the lecture series on 8051 microcontroller. In this lecture series, we are going to discuss about the role and importance of microcontroller in everyday life. Then the criteria for considering the choosing of microcontroller as well as use of microcontroller in the embedded system. Next, finally, we are going to discuss about various members of 8051 family such as 8051, 8052 and their features. Okay. So, these are all things we are going to discuss in this lecture. Okay. Let us recap of previous lecture. In the previous video lecture, I discussed about numbering and coding systems and code conversion, that is binary to hex and hexadecimal to decimal and vice versa. Then addition and subtraction of binary numbers and hexadecimal numbers. Then digital logic and design, in which we discussed about gates and some logic circuits like half adder, full adder, like that. Then the inside computer, what are all the blocks available, then internal working of the computer. These are all the things we discussed in the previous lecture. Okay. So, in this lecture, we are going to discuss about what is microcontroller and embedded processor and overview of 8051 family. Okay. So, what is the main difference between the microprocessor and microcontroller? So, if you take the microprocessor, means it consists of CPU, ALU and some registers, then some control unit. Okay. So, these are all things which is available in the microprocessor, but it didn't contains no RAM, no ROM and no IO ports and no serial port, no ADC, DAC. These peripherals are available as off chip only. Whereas, if you take the microcontroller, it consists of CPU, that is the microprocessor, it has on chip RAM, on chip ROM, IO ports, timer, ADC, DAC, PWM unit. These are all comes under a single chip, that we call it as the microcontroller. The RAM, ROM, IO ports, timer, UART, ADC, DAC, PWM unit, which are available in the microcontroller, we call it as an on-chip peripherals. Those things are available as off-chip in microprocessor. Okay. So, what is microcontroller? Okay, let us define the terminology microcontroller. The microcontroller is abbreviated as MUSI or UZ or MCU. It is a very small computer integrated on a single chip containing process core, memory, programmable input and output peripherals. It also is used for a one and only task. It is used for some dedicated applications, not for a general purpose. So, this microcontroller is often described as a computer on a chip. Okay. So, the microcontrollers, when you purchase as blank only, that is without programming. Once you are design that microcontroller for some particular application, so you are going to program with a specific control program. Once programmed, the microcontroller is built into a product to make a product more intelligent and easier to use. Okay. So, before programming, before downloading the programming, the microcontroller is blank only. Once you download the program to the microcontroller, it becomes intelligent. It may be dedicatedly used for some particular application. Okay. A designer will use the microcontroller to gather the input from various sensors and process this input by using the algorithms, then use the output mechanism on the microcontroller to do something useful. Okay. You can see these are all the some sensors. Okay. So, these are all the some sensors, these are all the output like actuators, it may be a motors or LEDs or speakers like that. Here this is some sensors, it may be a temperature sensors or LDR, whatever it may be. These are all the given as the input to the microcontroller. The program which is available in the microcontroller is going to process the input and take the action according to the controller algorithm which is available in the processor. Okay. Okay. Next one, this is the general block diagram of microcontroller and general purpose microcontroller. You can see here, as I told you earlier in the definition, this is the microprocessor. we call it as the mu p. So these chips are here, we call it as the off-chip peripherals, because these are all external to the microprocessor. You can see RAM, random access memory, read-only memory, I/O ports, timer, serial communication port, and so on. Okay. So these off-chip peripherals are connected to the CPU via data bus and address bus. Okay. So if you take the microcontroller means, so this is the microcontroller block in which the microprocessor is the part of the microcontroller. Microprocessor is a part of the microcontroller. In addition to that microprocessor, there are so many on-chip peripherals are available. Okay. What are all the things which are outside the microprocessor in the above said system, that is microprocessor based system? Here all the things comes under the single chip. You can see here you are having on-chip RAM, on-chip ROM, on-chip I/O lines, on-chip timer, on-chip serial communications, like that. Okay. So this is the main difference between the block diagram of microprocessor based system and microcontroller based system. Okay. Next, you can see here the microcontroller and microprocessor difference. General purpose microprocessors, we must add RAM, ROM, I/O ports and timers externally to make them functional. Without them, by using only the microprocessor, we can't do anything. Okay. So we have to add it externally. This make the system bulkier and more expensive. If you are adding these things externally, means it becomes large, and what happens? It is expensive also. Have the advantage of versatility on the amount of RAM, ROM and I/O ports. Depends upon the applications. If you want, means you can add the more amount of ROM and I/O lines also here in this case of the microprocessor. Okay. Whereas in the case of the microcontroller, it has fixed amount of on-chip ROM, RAM and number of I/O ports, makes them ideal for applications in which cost and space are critical. In many applications, the space it takes, power it consumes and price per unit are much more critical consideration than the computer power. Okay. Okay. So an embedded product uses a microprocessor to do one and only task. So usually the microcontrollers are used as the CPU in the embedded system applications. So the embedded system applications are used for one and only application. It is not going to be used for the general purpose applications. Okay. There is only one application software that is typically burned in the ROM. Okay. If you take the general purpose processors, means we are having the n number of apps are available. But in this case of the embedded system, there is only one application program which is permanently burned in the ROM. Okay. So in PC, what happens? There are a number of applications are available. It has the RAM memory and the operating system is available in your personal computer systems or laptops. That OS loads a variety of applications in the RAM and lets the CPU runs them. Okay. So the PC contains various embedded products. Okay. For example, even though I told that the PC is a general purpose systems, around the PC there are so many embedded systems are available in which a microcontroller is available. This microcontroller is going to be perform the task. Okay. For example, you can see here how many microcontrollers are available in a PC. You can see in your hard disk drive there is one microcontroller is available. In keyboard there is another microcontroller is available. In mouse you have the microcontroller is available. In modem or graphics card we are having the microcontrollers are available. For example, if you take the mouse, means what happens? It is job is gets the data of the position and gives a signal to the processor. Okay. So for example, if you take the hard disk drive, where to position, from where we are going to be take the data and where you are going to be write the data, in which track, for which sector, like that. Okay. So which locations, those things are decided by a small microcontroller which is sit inside the hard disk or in keyboard or in mouse or in modem. It does the modulation and demodulation if it on the graphics card. You can see around the PC general purpose system how many microcontrollers are available. Okay, these things we call it as the embedded systems. Okay, this is the internal real photograph of microcontroller terminals. Okay, so it is the 8051 based microcontroller chip. Then why you are going to be study the microcontrollers. Okay, so when comparing to the general purpose systems, the volume of the microcontrollers what we are using is 99% worldwide. We are using the microcontroller for so many applications. Okay, the PC based and workstation based microprocessors are 1% only. Okay, you can see in day to day life we are using the microcontrollers for various applications. Okay, it's from smartwatches, TV, ATM machines, so many things. Okay, in day to day life we are knowingly or unknowingly we are using the microcontrollers for various applications. That's why it is very important to study the microcontroller when comparing to the general purpose processors. Okay, you can see these are all the some of the applications of the microcontrollers for embedded system. Okay, in home appliances, if you take the home appliances means it is intercom, telephones, security systems, then answering machines, fax machines, camcorders, CCTV camera, musical instruments, sewing machines, light control and camera, toys, those things. In your office you can see in telephones, computers, security systems, fax machine, microwave oven, copier machine, laser printer, color printer, paging machines, like that. In automobile industries, you can see in the trip computer, engine control, airbag, ABS, instrumentation, security system, transmission control and keyless entry. Okay, these are all things in the automobiles. Okay, so in most of the manufacturers of general purpose microprocessors have targeted their microprocessor for high-end of embedded market. There are times that a microcontroller is inadequate for that task. When a company targets a general purpose processor for the embedded market, it optimizes the processor used for embedded system. Very often the terms the embedded processor and microcontroller are used interchangeably. One of the most critical needs of an embedded system is to decrease the power consumption and space, because most of the embedded systems are battery operated. Okay, so that's why we must optimize the power consumption. Okay, so it must be very handy also. That's why as much as possible we are going to reduce the size also. In high performance embedded processor, the trend is to integrate the more and more functions on the CPU chip itself and let the designer decide which features he or she wants to use. In many cases, using the general purpose processors for the high-end embedded applications, it saves the money and shortens the development time. A vast library of softwares already written. A Windows is a widely used and well understood platform in your general purpose systems. Okay, so next one, how to choose the microcontroller. If you take the 8-bit microcontroller, we are having more than dozens of 8-bit microcontrollers are available. So next the question is how to choose the microcontroller for your applications. Okay, for example, if you take the 8-bit microcontroller, you have the Motorola 6811, Intel 8051, Z8, microchip PIC. Okay, in addition to that, you are having 16-bit, 32-bit microcontrollers are available from various chip makers, manufacturers. Okay, so criteria for choosing the microcontroller for my applications. Okay, to choose, what are all the things you have to keep it in your mind while choosing the microcontroller for your application. First and foremost important is meeting the computing needs of the task at hand efficiently and cost effectively. For that, first one is speed. Okay, so while choosing the microcontroller, you have to choose the microcontroller with very high clock frequency. The package, what type of the package it comes around, the IC packaging. Okay, because as I told earlier, the space where it is going to be occupied is also very important in the case of the embedded system. Then power consumption. Okay, so it indirectly depends upon the battery life. Okay, if it consumes more power means we are going to be keep on change the battery time to time. So we have to optimize the power consumption also. Then how much amount of RAM and ROM on chip. Okay, because if you want to fuse the program to the RAM means it is also very important. Okay, so for example, if your program is going to be the too large means you have to choose the microcontroller with very high amount of ROM and RAM. Then amount of that is number of IO lines and timer. Okay. For your that is application, how many IO lines are needed? For my applications, sometimes 10 IO lines may be needed, 12 may be needed, 32 may be needed, 40 may be needed. Depends upon my applications. You have to choose the IO lines and the timer. How many timers you need? Sometimes you need 2 timers and 1 counters for some counting purpose, like that. Okay. Then how easy to upgrade to higher performance or lower power consumption versions. Okay. Then finally the cost also. These are all the things. The first comes under the first category. Next one, availability of the software development tools such as compilers, assemblers and debuggers. Once you choose the microcontroller, the vendor company itself, they are providing the IDEs. Nowadays they are providing the IDEs for the microcontrollers, integrated development tools. Okay. For example, in older days it's very difficult to write the program by using the assembly languages, but nowadays they are providing the cross compilers where you can use the high level language also. By using the high level language, you can write the program either by using the C or C++ or Python or Java, like that. Okay. So for that it supports the high level language to convert into machine language. For that you need some cross compilers. Okay. So what are all the systems that is microcontrollers which supports the compilers, assemblers and debuggers and emulators. Okay. So you have to keep it in mind what are the software development tools that supports your selected microcontrollers. Next one, wide availability and reliable sources of the microcontroller. So what happens, for example, if you take the 8051 family, means it has the largest number of diversified, that is multi-source suppliers. Okay. For example, you must choose the microcontroller like this, because now for example this year you are choosing one microcontroller for your applications. Okay. After 20 years, if that microcontroller is not available in the market, means some other sources, some other vendors may supply, if it is the diversified supplier. If you take the 8051, means the original is Intel. In addition to that, Atmel is also producing, Philips also producing, AMD is also producing, Mantra is also producing, Dell is also producing the same 8051 microcontroller with small modification. The small modification means they are going to be add some extra RAM or ROM or some more instructions, like that. Okay. So these are all the 3 important criteria you have to keep it in your mind while choosing the microcontroller for your application. Okay. Next one, these are all the common microcontrollers which is available in the market. Okay. So as I told you earlier, so the Intel is the 8051 series, then Atmel, ARM processors, these are all the Intel, the National Semiconductors. This is the one of the popular RISC processor, RISC. Okay, I will come to that point later, what is the RISC and CISC processors, but the expansion of the RISC is reduced instruction set computing. Okay, so it is supplied by the PIC microcontroller is supplied by the microchip. It has the 12-bit, 14-bit and 16-bit is available. Then Motorola, now it is called as on the Freescale Semiconductors, it is the 8-bit, 16-bit and 12-bit, 32-bit series is available. Next, the Texas series, this is the most popular digital signal processor. Okay, the Texas Instruments, the TMS 320, 370 series are digital signal processors. Next one, the Zillock. Okay, somewhat it is equivalent to the Intel only, Z8 and Z86002. Okay. Next, coming to the 8051 microcontroller. Okay. So our aim is we are going to be study about the 8051 microcontroller. The 8051 microcontroller is introduced in the year 1981 by Intel. Okay. So it is the 8-bit microcontroller. It is the 8-bit microcontroller. That means 8-bit means it is the 8-bit CPU and 8-bit ALU. It is going to be processed 8-bit at a time. For example, the processing means if you want to do any addition or subtraction, whatever it may be the manipulations you are going to do, means it is going to do 8-bit at a time only. Okay. So if you take the 8051, means it is the most very popular microcontroller. Okay. After allowing the other manufacturers, that is the meaning that I already told, the diversified manufacturers. When it becomes so popular, means it's widely popular after allowing the other manufacturers to make and market any flavor of 8051 by remaining the code compatible. That is very important. Okay. So whatever it may be the you are programming in 8051 is it is compatible with Atmel or Zillock or Philips or Dell's. Okay. So under the agreement only the Intel sold the library to some other manufacturers also. Okay. So this is the general block diagram of your 8051 microcontroller. Okay, I will give the overall introduction about the 8051 blocks. These are the things we are going to be discuss in the forthcoming video lectures. Okay, you can see this is the one of the 8-bit microcontroller. This is all in a single chip now. Okay, it has the 32 number of I/O lines. Then this is the on-chip UART. Okay, then you are having the 2 number of timers. Then you are having the 256 amount of RAM, and you are having 8 kilobytes of ROM. These things are available in a single chip of 8051 microcontroller. Okay, so the 8051 family. Okay, next one, this is the 8051 microcontroller. Then in a 8051 family, the 2 more members are available. Okay, the 8052 and 8031 is the subset of 8051 microcontroller. The 8031 is the microcontroller which is similar to the 8051, but it is, we call it as the ROM-less version of 8051. Okay, so if you are using the 8031 microcontroller, means you have to add the external ROM only. Okay, you can see here, this is 8051. As I told you earlier, it has the 4 kilobytes of ROM, 128 bytes of RAM, and 2 numbers of timer, and 32 I/O ports, and 1 serial port, and 6 interrupt sources. If you take the 8052, another family member, subset of 8051 means twice the amount of ROM, that is 8K, twice the amount of RAM, that is 256, 1 more timer is available, 3 timers are available, same amount of I/O lines, and same amount of serial port, and 2 extra interrupt sources are available. So totally 8 interrupt sources are available. Okay, if you take the 8031, as I told you earlier, this is the ROM-less version of your 8051, that is 0 kilobytes of ROM, and same 128 bytes of RAM, same number of timer, same number of I/O lines, same number of serial port, and same number of sources. That's why I told that it is the ROM-less version of 8051. Okay, so then some other family members are 8751 microcontroller is also coming from the Intel family. This is the UV-EEPROM. Okay, so if you want to program the ROM, you need the EEPROM burner you need. Okay, so for programming and burning, that is erasing the data, minimum you need 20 minutes. You have to wait to erase the data. It is one of the drawback in your 8751 microcontroller. Then if you take the next enhanced version from the Atmel Corporation, 8089C51, it consists of flash memory. Okay, so the ROM burner that supports the flash, a separate eraser is not needed. Okay, within a fraction of time you can erase those data. Okay, it's a very good advantage when comparing to the previous 8751. Okay, next one is the Delos DS89C 4X0 is the part of the Maxim Corporation. It has the flash memory, comes with on-chip loader, and loading the program to on-chip flash via PC COM port. Okay, next one, the DS5000 from Delos Semiconductor. It has the NVRAM, change 1 byte at a time. Okay, no need to erase the whole data. It is, if you want, means remove or that is you have to load the data a byte in a memory location, means it is possible. It has the real-time clock also, comes with on-chip loader. Okay, next one, OTP, that is one-time programmable version of 8051 is available. Okay, for example, if you are using the 8051 for laboratory purpose or any research purpose, means you can use the previous versions. If you finalize the program, if you want to fuse and you can use it for any commercial applications, means better you can use the OTP version of the 8051. Once you can fuse, means you can't, it is not possible to erase the data. Okay, so once you finalize the program, it is working properly, means we can go ahead with the OTP version of the 8051. Okay, so as I told you earlier, you have the 8051 family from Philips also. It has the additional ADC, DAC, not additional, the ADC, DAC, this is not available in the Intel 8051 family, but the Philips introduced the ADC, DAC, some more number of IOs and OTP and flash. These features are incorporated in the 8051 family from Philips. Okay, so you can see this is the packages, microcontroller package types. Okay, the same 8051 comes in the different packages. Okay, you can see the ceramic through hole package, that is CPGA. Next one, this is the SDIP, that is the plastic through hole package. This is HDIP, plastic through hole package with a higher heat dissipation rate. Okay, this is PLCC, plastic lead chip carrier. Okay, next one is QFPP, quad flat package. Okay, then HSOP, plastic dual construction surface package with higher dissipation rate. These are all the various packages of 8051 family. The same 8051 microcontroller comes into the different packages. Okay, so let us summarize the things, that is what are the main feature of the 8051 microcontrollers. Okay, this first one, this is the 8-bit microcontroller. It has the registers A and B. These things we are going to be discussed elaborately in the forthcoming lectures. It has the 8 kilobytes of ROM and 256 bytes of RAM. In the 256 bytes of the RAM, the first 128 you can use it for general purpose register, remaining 128 you can use it for, that is 0 to 7F is the 128 bytes, you can use it for general purpose register, remaining 128, that is the whose address is 82FF, is used for special function registers. Okay, so then they are having the internal and external interrupts are available, and oscillators and clock circuit is available, and control register, that is special function registers, so many things are available. So for example, it is PCON, SCON and T mode and TCON and IE and IP. These are interrupt related, these are timer related, this is serial communication related, this is power control related, and 2 numbers of timer, 16-bit timers and counter is available, and one program counter and one 16-bit data pointer is available, and IO lines is 32. It has 32 IO lines. It is grouped into P0, P1, P2, P3, each contains 8 IO lines. So totally you are having 32 IO lines are available. Then stack pointer and program status or processor status word, this is also available. Then one serial communication port, that is UART with full duplex operation is available. Then it has the 8-bit data bus and 16-bit address bus is available. So it is having the 16-bit address bus, you can connect the external RAM up to 2 power 16, that is 64 kilobytes of RAM you can connect. Okay, so if you are connecting the 64 kilobytes of RAM, means you are losing the 4 ports P0, P1, P2, P3. Okay, so so you have to keep in that mind also. Okay, while connecting the external memories. Okay, so then additional features are on-chip oscillators, Boolean processors, power down mode. These are the things, some additional features. This is available in your 8051 microcontroller. Okay, so let us summarize the thing, what all things we discussed so far in this video lecture. First I discussed about the microprocessor and microcontroller and applications of the microcontroller, how the microcontrollers are used in embedded systems. Okay, so what are the applications of the microcontroller? Then 8051 family we discussed, and block diagram of 8051 family and features of 8051 family. These are all the things we discussed in these video lectures. So the reference of this video lecture is the Muhammad Ali Masdi by 8051 microcontroller and embedded system by Pearson publication, 2nd edition I am used. Okay, so in this next video lecture we are going to be discussed about assembly language programming of 8051 microcontroller. Okay, so in the 3rd video lecture we are going to be concentrate on addressing modes, registers, on-chip RAM and on-chip ROM and interrupts, how you are going to program the on-chip ROM, RAM, those things. Okay, so thank you.